Hey guys, just to let you know that you can catch these lessons live every Thursday from 6 PM until 7 PM UK or BST time, and that will just allow you to ask any questions that you want and get some answers to them. Without further ado, let's get on with the lesson. Okay, welcome back to another one of my free A-level maths tuition sessions. This is the 6th one, and today we're going to be covering sketching and transformations. So just so you're aware, transformations does come back later on in the course. So this is mainly for AS, okay? This is like the AS transformations, and there are a few more that you need to know for A2, but this is going to be a bit of a recap as well for what you did in GCSE, really. So whenever you have transformations, what they'll do is they'll give you like an equation. So it might look something like this, right? Or they'll say, apologies for the terrible drawing, they'll give you that this is the graph of y equals f of x, right? And it'd be like whatever kind of shape. And then they'll ask you to transform it. So it'll either look like this or it'll look like this. Either one is fine. And then what they'll do is they'll say f of and then some kind of transformation, okay? So what we need to remember is inside the bracket, so for example, this could be something like f of 2x or f of x plus 3, for example. So if it's inside that x bracket, then you do the opposite. You do the opposite, okay? And you only touch or affect the x coordinates. Okay, so f of 2x, you do the opposite. So that says 2 times x, so we're going to do divide by 2, and we only affect the x values. Okay, so this would be a compression in the x-axis. And then with x plus 3, it's saying plus 3, so we do minus 3, okay? Now if it's outside the bracket, so for example, this could be like 2f of x, or it could be f of x plus 2, something like that. You do what it says, and it affects the y coordinates. Okay, so just let me check on the stream quickly. Okay, yeah, and it affects the y coordinates only. Okay, so what this would do for 2f of x, it would times all the y coordinates by 2. F of x plus 2, you'd add 2 to all the y coordinates. That should be fairly simple so far, okay? And this is a bit of a recap of what you did in GCSE, but again, you have to be able to do it to A-level kind of graphs that you know, so sine and cos and tan. You have cubic graphs, etc., and then just random graphs that they can give you. But there is also some more stuff that you do in A2, which we'll come across in another lesson. So if we start just doing some of these questions, as you can see, you get quite a few marks for these, and this is kind of a typical exam question. So we didn't go over what sketching is, but that's because I wanted a good example, and this would be a good one. So they tell me that f of x equals x plus 3, x plus 2, x minus 1. Okay? And we need to actually sketch what that curve is, showing the points of intersection with the coordinate axes, and that's 3 marks. So I'm going to show you what you get the marks for now. So if for part A we're just sketching, let's draw. This is like this. Your marks come from the y-intercept and all of the x-intercepts. Okay? So this is actually going to be 4 coordinates for us, but you only get 3 marks, and you drop a mark for every single one that you don't get. So to work out our y-intercept, that is when x equals 0. So if we do that now, so y int, we're just going to sub in x equals 0. So then f of 0 is equal to x plus 3 now becomes 0 plus 3, so it becomes 3. X plus 2 now just becomes 2, and minus 1. So that is just going to be minus 6. So our coordinate there is going to be x is 0, y is minus 6. We can even put that on the graph right now. Okay. And again, in terms of like where these values are, as long as you keep it roughly proportional, it's fine. You don't have to be super accurate with it. Now with an x-intercept, that's the opposite. That's when y equals 0. So what we're going to do here is we're going to say 0 equals x plus 3, x plus 2, and x minus 1. Okay, now we know how to solve this already. It's the same as solving a quadratic. We set each of these brackets equal to 0. So either we have, well, in this case we have all of them, x plus 3 equals 0. So minus 3 from both sides, we get x equals minus 3. We have x plus 2 equals 0. So then x equals minus 2. And then lastly we have x minus 1 equals 0. So x equals 1. So if we plot these, we would have one, let's spread it out a bit. We have minus 3, minus 2, and 1. Now, in terms of which way this comes, so we have to, this is a cubic graph, right? So in terms of which way this kind of comes from, there are two ways you can do this. What we can do is sub in a value of x that's less than minus 3, okay? Now, if it's negative, it means the graph starts from here. If it's positive, it starts from up here, okay? But there is also kind of a rule that you can remember as well. So let's sub in f of minus 4 and see what we get. So if we just sub this in on our calculator to make it a bit quicker for us, we would have minus 4 plus 3. Then we have minus 4 plus 2. Then we have minus 4 plus, minus 1. Which gives me minus 10, so it's negative. Okay? Which means I start from the bottom and go up. So we're going to go up. And what it does is it kind of threads the needle like this. Okay, let's move the 1 over here now because I'm... And that's what our graph will look like. Okay? So again, it needs to be clear where the coordinates are. If you've written them down, then you're actually you're fine. It doesn't need to be too clear. Okay? But in general, positive cubics start from the negative side. And negative cubics, shockingly, start positive, okay? So what I mean by that is if we expanded this whole bracket, the x cubed is going to be positive because it's x times x times x. If there was a minus in front of one of the x's, then it would start from the top, which makes sense because it would flip the sign. And that's it for part A. So that's 3 marks. So again, you lose a mark for every coordinate you don't have on there. So we have 3 x-intercepts and 1 y-intercept. Now if we scroll down a little bit, we have part B, part I, and what it says is showing the coordinates of the points of intersection with the coordinate axis. So sometimes they don't tell you that, but essentially when you do transformations, all of these points, you need all of the x and y intercepts again, okay? Sketch on separate diagrams the curve. So first one is y equals f of x minus 3. We could do part 2 next to it here, which is exactly what I'm going to do actually because it makes it a bit easier for me. And y equals f of minus x. So what I like to do is ask myself what's actually happening. So for this first transformation, remember it's inside the bracket, which means we do the opposite and it affects x. So we're doing x coordinates plus 3. So all of these x coordinates are now plusing 3. So instead of minus 3 we have 0, instead of minus 2 we have 1, instead of 1 we have 4. We're literally just dragging the whole thing across. Okay? And again for f of minus x, so again if it's minus x, it's basically minus 1 times x. So the opposite of timesing is dividing, so you're dividing by minus 1, which is the same as timesing by minus 1. So all you're going to do basically is flip the sign of the x coordinates. And just so you're aware, what this basically is a reflection in the y-axis. Okay, so not too shabby, I think. So let's get started. So if we start down here, so we have our graph. And again, I made the right hand side slightly longer because if you notice, all of my coordinates are now going to be shifted over. And okay, so this coordinate 1 is now going to be 4. This coordinate minus 2 is now going to be 1, which I'm going to put over here. I've made this quite long. And that one's going to be 0. Okay. Now what you can do is actually make put the minus 6 on there too, as well, I should say. So instead of being 0 minus 6, it's actually going to be 3 minus 6, so somewhere over here. You don't need to do this though. Okay. And basically it's still a positive cubic, so it's going to come up from the bottom. And hopefully that makes sense, right? When I add 3, I'm just moving it all across, which means it should still start from the bottom. Have we labelled all of the coordinates? Well, if you look, the y-intercept is just 0, 0 in this case. So we do have the y-intercept. So we have 1, 2, 3 x-intercepts, and we have the y-intercept. You don't need this point, but I like to put it in there anyway. Okay, but the actual marks you get for 1, 2, 3, and then technically 4, even though it's only a 2-mark question. Okay, because you don't actually have to work out the coordinate axes. Okay, so let's get started with the next question. We have y equals f of minus x, so we're just flipping the signs. So this will be plus 3, plus 2, and that'll be 1. And this is actually going to be a bit more interesting. Oh, God. Okay, so if we plot these now, we have 1 at minus 1. Then the other ones we have are at 2 and 3. Now our y-intercept is 0 minus 6. So if I times 0 by minus 1, I still get 0. So this actually stays perfectly the same. So all my points are there, that's good. Okay. In general, with these kinds of questions, when it's a 2-mark transformation, you get 1 mark for getting the coordinates correct, and you get 1 mark for the shape being correct. Okay. Now, in this question, however, if we reflect this in the y-axis, can you see it's going to start from the top? So we actually need to start from here. And if you look, it's not perfect, but this graph and this graph are just reflections of each other. So where this one ends with an upwards flick, we've started with an upwards flick. And then other than that, it looks the same. Okay? So that's where the shape mark would come into play. If you went from the... To be fair, if you have a look, if I started from the bottom, right? So I started doing this. How can I now go through minus 6 without crossing the x-axis? It's impossible. So I know it goes from the top anyway. Okay? Hopefully that all makes sense. And let's go on to the next one. So again, something else that they can ask you to do when it comes to sketching is actually solving certain equations as well. So first off, we need to sketch on the same diagram x squared plus 5x and y equals minus 1 over x. So I would actually say sketching the minus 1 over x is easier first. For those of you that may not know, the y equals 1 over x graph looks like this. Okay, so it goes like that, where the x and y axis are actually asymptotes, which means the graph will never cross them. So make sure you don't make it touch. And so if it's a minus 1 over x graph, it means that it's going to actually be flipped. Okay, so it's actually going to be over here and here. Okay, so let's start with part A. I'm going to make this quite big just so I can ensure. So again, this was 1 over x. So minus 1 over x means I'm flipping the x coordinates. I'm reflecting it in the y-axis. So we're going to have that top right is now in the top left, and that bottom left is now in the bottom right. Now you might be wondering why I'm not putting the asymptotes on here. It's because we have x squared plus 5x as well, which is not going to look... Sorry, it's going to cross the x-axis, so we can't have asymptotes. So now with y equals x squared plus 5x, if you remember rightly, we need to have x-intercept and y-intercept. Okay? So, if I want to work out the y-intercept, that would be the easiest one to do. I sub in x equals 0, so I have y equals 0 squared is 0 plus 5 times 0 is 0. So in other words, it crosses at the origin. X-intercept, I have y equals 0. And to solve that, we need to factorize. So the biggest thing I have to take out is x. So either we have x equals 0, which we do because that's this point over here, or we have x plus 5 equals 0, so x equals minus 5. So we can make minus 5, let's say, over here. Actually, let's move it over a little bit, because what we're going to have is a big U shape. And it's a U shape because it's a positive quadratic. So yeah, that's not bad. Not bad. And that'll be 4 marks. Okay? So you get a mark for the shape of both of these, right? So a mark for here, a mark for here, a mark for having the x-intercept, and a mark for having the other x-intercept, which is also the y-intercept. 4 marks. Not too bad. Now here's where things get a bit interesting. So this was in your GCSE spec, but it has never really come up in the exams, so you may not remember it. So I have an equation like this. It says state giving a reason the number of real solutions to the equation. Now, this is a part B, and it's also only 2 marks. And it also says giving a reason, which means we should be able to get to the answer pretty quickly. Now if I have a look, x squared plus 5x was y in this equation. Now I can get 1 over x, I have 1 over x here. I can get minus 1 over x if I move this to the other side. So if I have x squared, I can actually get both of my equations by doing this. Moving the 1 over x to the other side. Now if you look, the left hand side is that quadratic and the right hand side is the other bit. This isn't a coincidence. This is why they wanted it on the same diagram. Because you can see, you can actually read off the answers to this equation by just reading off the coordinates where they cross. Okay? And every time they cross, there is a solution to this equation. How many times do they cross? It crosses once, so there's only one solution. So one real solution as the curves cross once. Or you can say intersect, which is sometimes like a better word to use. So one solution is 1 mark, a good reason is the 2nd mark. Okay? Not bad. Okay, let's keep pushing forwards. Okay, the sketch shows the graph of y equals f of x. The curve has a minimum at -3, -2, and a maximum at 4, 7. Showing the coordinates of the points of the intersection with the coordinate axes, sketch on separate diagrams the curves f of x plus 2 and minus f of x. Okie doke. Okay. So we are going to have to keep referring back. I don't really need to put the number 3. So f of x plus 2, let's think about what that does. What it does is it adds 2 to the y coordinates. In other words, it's going to shift all of this stuff upwards. That's it. Drag and drop. So let's do this. Again, your axes don't have to be huge, but I prefer to make them decently large just to make sure that I get the points. And the first thing I do is plot the points. So instead of -3, -2, add 2 to the y coordinate makes it minus 3, 0. So it's actually, that is the x-intercept. And lastly, we have this. So instead of 4, 7, it's going to be 4, 9. Okay. And it just looks like a big, like, snaky boy. So like that. Yeah, that's not going to work. Okay. It would be a lot easier if I could look at the question at the same time. Right. That is absolutely perfect. Okay, and those are the 2 marks. Okay, so if you notice in the actual question, just in case you're wondering why I'm not putting the y-intercept, we don't have it. And we can't really work it out. You can work it out, but it says the intersection with the coordinate axis. Right, axis is 1, axes would be both. So it's only the ones that actually cross. Okay. And for part 2, we can probably just leave it like this. We have y equals minus f of x. So what it does is it's timesing the y values by minus 1. So it's just flipping the sign of the y values. So flip sign of y coordinates. Okay. And that's all you need to do. So instead of minus 3 minus 2, we have minus 3 plus 2. So again, let's draw our little axes out. Okay. Minus 3 minus 2 now becomes minus 3 plus 2. And one thing to note is that when you have a minus f of x, it's the same as a reflection in the x-axis. So that may sound a bit fancy, but all you're doing is you're taking it and flipping it over. Okay? And then you also have 4 minus 7. So 4 minus 7. So again, now instead of it going down and then up, it's going to go up and then down, because again we're flipping this, rotating it 180 degrees, right? So it's going to go up, like that. Yeah. Oh, and that would be it. So those are the new coordinates that we have. And in terms of the y-intercept, if you notice, it's actually stayed the same. Because all we're doing is reflecting it, so it might actually cross out a bit lower. Yeah. Okay, 8-mark question, so pretty beefy, so brace yourselves. And it says 4, we have equals x squared. Okay, and it says sketch it in the form this. Now this form always means completing the square. Okay. Now there's a trick with completing the square, you probably already know, and that it gives you the coordinates of the minimum point of any graph. Okay, so that's exactly what they're asking us to do here. Now, I'll explain how the trick works, right? But you can just memorize it, but I'll explain why it works as well. Now with the completing the square, if you remember, you have x squared plus bx plus c. That now becomes x plus b over 2 squared minus b over 2 squared plus c on the end. So let's now sub our thing in. We have x, 4 over 2 is going to be 2. So x plus 2 squared minus 2 squared plus 5. So we have x plus 2 squared. Now 2 squared is 4, minus 4, and then plus 5, so we have plus 1. So basically the trick on the minimum point is, so if we write min, is, all you do is you flip the sign of the inside of this, and that gives you the x coordinate. And then you keep the y coordinate the same. That's it. Now the reason why this works is if we look at this as a function, right? What is the smallest thing I can make this overall expression? Well, that might be a bit hard to work out. What's the smallest thing I can make this bracket? Since it's squared, if it's negative inside, it will then become positive once it's squared, right? Which means the smallest thing I can make that bracket is 0. Now, how can I make it equal 0? Well, if the inside equals 0 and I'm plussing 2, x has to equal minus 2, so that's why that works. Now, if I do make that bracket equal 0, then I have a plus 1. So the smallest value f of x can give me is plus 1, which is where the 1 comes from. So that's where that comes from, okay? I hope that makes sense. Okay. Perfect. So you may know that this is not going to have an x-intercept now, because the lowest value it can be on the y-axis is 1. So now if we, for part B it says we need to sketch it. But yeah, this is 3 marks, by the way. So all it is completing the square and that's it. But this is our answer, and that's another way we managed to get to our answer. We need to actually sketch the graph now. X, Y. Okay, so we have the minimum point. There are no x-intercepts, right? And if you tried to work it out with this one, you'd get a math error because you have to put the 1 to the other side and square root it. You can't square root a negative number. But the y-intercept, though, all we need to do is sub in x equals 0. And if we look at that expression, I'm hoping you can see we have x squared is 0 squared, so 0. 4 times 0 is 0, plus 5 is just 5. Right? Other way to do it is 0 plus 2 is 2. Squared is 4, plus 1 is 5. Either way. So it crosses at 5. Let's make it relatively high. And then we've got minus 2, 1 as the minimum point. So it looks something along the lines of that. Okay? Now, of course, I didn't really need the x-axis to be that long. I could have kept it more in the negative. So you don't have to make it even, if that makes sense. You can like skew it to one side. So I could have cut off maybe this much of the x-axis, but it's completely up to you. But that's 3 marks. So you get a mark for the shape, the coordinate, and the y-intercept, because there is no x-intercept. So really, not too bad really. And then all it says is find the minimum points of these curves. Now this is interesting, because if we just need the minimum point, I don't need to sketch it. Okay? And for the first one, it says y equals 2f of x. So what does this do? It timeses, so times y coord by 2. So if I'm just finding the minimum point, I know that the x value is still minus 2 because we haven't touched the x value. And what are we doing to the y value? We're doubling it. So minus 2, 2. Cool. That's literally it. Not too bad. Not too bad at all. And then for part 2, it says, do the same thing, but for y equals f of 2x. Now remember, if it's inside, we do the opposite and we affect x. So we divide x coord by 2. So now we have the second value, it's going to be 1. The first value is going to be half of minus 2, which is minus 1. That's it. Not bad for 4 marks, I would say, for part C. So hopefully this is making some sense at the moment. Okay. Let me put that on my stream. Okay, dibs. Okay. So 5A. minus 5x, okay? And we need to sketch this curve showing the points of intersection with the coordinate axis. So I can already tell you we need to factorize this, but remember what we need. We need the x and y intercepts. The y intercepts don't know what I was going to say there. Generally are far easier to work out. You just need to sub in x equals 0. So what we have is f of 0. And if you notice, there's x in every single one of these terms. So f of 0 is 0. So our y-intercept is 0, 0. Done. Now for the x-intercept, where we need f of x to equal 0 or y equals 0, we have this. So if I do it over here, we have x cubed plus 4x minus 5x equals 0. So, 4x squared, sorry. So we need to do some factorization. So pull out an x, and we get x squared plus 4x minus 5 equals 0. So that x is what gave us the x equals 0 y-intercept. So that's pretty damn good. And now we need to factorize what's inside the bracket. So we're looking for something that times is to minus 5 and adds to plus 4. So you're looking for 5 and minus 1. So we have x plus 5, doesn't really matter the order, x minus 1 equals 0. So now my value for the x-intercepts are either x equals 0, x equals minus 5, x equals 1. You just flip the sign of what's inside the bracket. So all of the points we have now are 0, 0 again, so we don't need to put both of them if we don't want to. We also have minus 5, 0, and we have 1, 0. So if we're sketching this now, we have x. Now sketching cubics and also quartics and things like that, it can be a bit tricky, okay? But it's not too bad at the moment if you want to do it. So what we're going to do here is we're going to put the minus 5 here, the 0 is here, and the 1 is over here. And again, it's a positive cubic, so it starts from the bottom. Just like that. And that is all you need to do. For two, sorry, how many marks is that? That should have been 3, yeah, good. Okay. Then for part B, part I, showing the coordinates of the points of intersection with the coordinate axes, sketch on separate diagrams, f of x plus 1 and 2x. Okay, so f of... So again, let's think about what we're doing here. We're subtracting 1 from x coords. So if we have a look at all our values, all we're going to do is move everything to the left. So that's not really too tricky to do. Let's just draw our x and y values. And then all we're going to do is subtract 1 from all of the x values. So minus 5, we're going to move that to minus 6. Now remember, this is also a root which has coordinates 0, 0, so we need to subtract 1 there. So it's minus 1, 0, minus 1, and the last one is still at 0. So we're doing the exact same thing, we're just shifting everything along and drawing a beautiful looking graph like that. Okay. Perfect, and then for 2x, remember it's inside the bracket, so we do the opposite and affect x. So what we're going to be doing is dividing x coords by 2. So again, it's going to the same thing, it's just going to be squished in. So once again, let's draw our axes. So instead of minus 5, it's now minus 2.5. And I like to actually make the shape a bit thinner as well. 0, 0 obviously stays the same. And 1 is going to now become 0.5. So we can actually make the shape really thin now to... So technically the actual height should be the same. So it should actually still go like this. So it should still reach the same height as the previous one. It's just compressed inwards. It gets there faster. So hopefully that makes sense. Okay. So once again, we actually went through the shape of this graph at the beginning, so y equals 1 over x. So if we think about what's happening here, is if we say that y equals 1 over x, or rather if we say this is f of x, then what they're doing here is asking us to sketch y equals f of x plus 2. So everything's going to be shifted upwards. Now you need to be really careful because this equation does actually have intercepts of its own. So if you remember with the 1 over x graph, you have something that looks along the lines of this. Goodness gracious. Right? And the asymptotes are along here. Now, if I were to drag the graph upwards, it is going to meet the x-axis at a point over here somewhere. So we need to be really careful of that. It also means the asymptote is going to move upwards, which we have to label. So giving the equation of any asymptotes, as it says in the question. But this asymptote here along the y-axis is going to actually remain identical to what it looks like now. So what we could do is it going to cross the y-axis? The answer is no. But what we can, because if we sub in x is 0, we get something hideous and disgusting, is if we want to find the x-intercept, right, if you remember rightly, all we need to do is find when y equals 0. So we have 0 equals 1 over x plus 2. Move the minus, make it minus 2 equals 1 over x. Times it, we have minus 2x equals 1. So x equals minus half. So let's draw it. We're going to have something along the lines of, so it's going to look similar to this, but I would like to draw the asymptotes first. So this asymptote here, we would call it y equals 0. We move it up by 2. So we're going to have a dotted line going along here at y equals plus 2. Now none of our lines should meet that. We also have, it says giving the equation, so what we do is write that as x equals 0. And now we draw our graph. It's going to look the same, it's just going to, and again be careful, make sure it doesn't look like it's crossing the x-axis, the asymptotes, because if it looks like it crosses, if it touches at all, you lose the mark for shape. Okay, and this coordinate here is minus a half 0. And that's it. So you should be able to transform pretty much any graph even if you're not familiar with it, just by thinking of what this shape is and then what I'm doing here. Now, what some students ask me is what would it look like if it was the same question but it was f of x plus 2? Then you'd have something along the lines of 1 over x minus 2, and that's what you're plotting. Okay? So for it to be inside the bracket, it needs to be in the same part of the function as x. Right? So if you look, this is the main function here, and then we're adding 2 to it. If that plus 2 was here in the same function, which is a divide, then it would be inside the bracket. I believe this is the last question for today. Again, not a super long lesson, but it doesn't look like any of you have any questions for those of you that have turned up. So again, remember, if you are unsure of a topic, it's good to show up to these to make sure that you're kind of okay with it, but then you can also ask questions, because I can't exactly answer questions. I mean, I can answer questions afterwards, obviously, but it's easier when I'm actually at a whiteboard, so to speak. So once again, sketch this curve, 3 marks. We should be fairly okay with doing this now. If I want the y-intercept, which again is the easiest, we're subbing in x equals 0, right? So we have plus 4 times minus 1 is minus 4, times 2 is minus 8. So our y-intercept is 0 minus 8. X-intercept, which is when f of x equals 0, or y equals 0, whichever one you want to call it. All we're looking at is the fact that x plus 4, x minus 1, 2 minus x, so be careful they've kind of written this backwards, equals 0. So we have either x plus 4 equals 0, so x equals minus 4. We have x equals 1. Now with this one, you have to be careful. You have 2 minus x equals 0, so x equals 2. Okay? So be careful with that. The shape of this is also going to be a bit tricky, because one of the x's is a minus. The overall x cubed is going to be minus x cubed, right? X times x is x squared times minus x is minus x cubed. Remember, when I say it's a negative cubic, I only care about the x cubed bit. Everything else can be negative or positive. It doesn't really affect if it starts from the top or bottom. But since this is negative x cubed, it starts from the top. Okay? Because again, if you expanded that. Cool. Let's keep going. X, Y. I like to put the these values first. So we have minus 4 over here. So 1 would be something like here, and 2 would be something like here. It's not actually, it's not bad. And 0 minus 8, so it crosses somewhere like over here somewhere. And it starts from the top, so it's going to look interesting to say the least. So down, and then it has to kind of, so basically when it goes through minus 8, that doesn't have to be the bottom of the curve. It's not necessarily the minimum, right? The minimum could be over here. So since what I like to is I'll draw it like this, and it looks a bit more natural, and that would be your full 3 marks. A mark for the curve, and again remember the next 2 marks come from having all the right points. There are 4 coordinates. They give you 2 points, but it's not 2 marks, which it's not half a mark each. You drop 1 for every one you get wrong. Which, yeah, sounds a bit crappy, but is what it is. Part B, sketch on separate diagrams. Cool. So if we look at part B, the 2 equations are f of x plus 2 and minus f of x. Minus f of x. I think I'm going senile. My memory is poor. Okay. So, sketching this, nice and easy. Oh, hang on, there is actually one thing I forgot to do. So, plus 2 on the inside, it's minus 2 from x coords. And minus f of x means I'm timesing y by minus 1. So in other words, I'm just flipping the sign. So flip sign of y, which is the same as saying a reflection in the x-axis. Because keep in mind, one thing that some students kind of get wrong is that this transformation affects every coordinate along this line. Every single one. So the reason why I say students get it wrong is because we like to focus on these points here, and that's a good thing to do, right? We only focus on the important points because there's an infinite number of coordinates. So we focus on the important bits. But keep in mind that this minus f of x, it doesn't mean the shape will be the same, but this is like on the other side. It means it's actually starting from the bottom. So times this y coordinate by minus 1, you're starting from down here. Times this one by minus 1, you're ending up here. The whole thing is changing. So minus 2 from x. This actually isn't too bad. We have minus 4 here, so that becomes minus 6. Then we have 1, which would become minus 1, which I'm going to put over here. 2 becomes 0. And if you want, you can put this as minus 8, minus 2, minus 8, but it's not necessary. And like I said just now, is instead of it coming from the top, it's going to come from the bottom. Whoa, hang on a minute. No, that's fine. I scared myself, sorry. You go down, and then up, and then down. Easy. And for this one, if you notice, all of our coordinates except 1 is actually going to stay the same anyway. And that's again why I caution. I encourage caution. Because the only coordinates changing is this minus 8. Everything else is actually the same. But the shape is completely different. So that minus 8 now becomes a plus 8, and this still stays as a 1 and a 2. Okay, so that's a really key thing to remember with that. And again, it's starting from the bottom. And a perfect reflection. Again, you don't have to be like Michelangelo. It's okay to kind of make, you know, it not be perfectly the same. And it's a sketch, right? So the main thing is the coordinates and the general shape, right? Like if I join these points up like a zigzag, that's wrong. Or if I did something like I went up and then straight line or something, you know, like something weird like that. You need a general shape. Okay, I think that's pretty much it for everyone. I think everyone's perfectly fine with this. So I'm going to call it quits here. So again, remember you can join these live streams 6 p.m. every single Thursday. You can ask questions, you can do all of this fun stuff, and also make suggestions, right, to make it as useful as possible. But I'll see you in the next one.